Okay, let's we continue the lecture. Okay, so this is another example that I'm going to demonstrate for the virtual method in the frame. Okay, so actually this frame we have analyzed in the example 2. So we have produced the bending moment, shear force and SL diagram. Okay, and we will use this diagram again, but we will solve for the vertical displacement at joint C. Okay, so as usual, for the virtual method, you need to have a two diagram. Okay, so which is a real diagram and a virtual diagram. Okay, so the real diagram is based on the actual diagram in the equation. Okay, so meanwhile for the virtual diagram, you need to apply 1 unit load vertically at joint C, since the equation is about the vertical displacement at joint C. Okay, so and the numbers of cut sections for this member AC is 1, and same goes for the virtual diagram is 1. Okay, so but in a CB, okay, for the real diagram you can see that they have two numbers of cut section due to this 1.40 constant point load. Okay, but in the virtual diagram you only have one numbers of cut section, but you need to have two numbers of moment equation. Okay, so in order to tally with the real diagram, so meaning that the equation, the moment equation for this member, which is a B to this point and this point to C, is similar. In other words, you just need to cut one time. Okay, so it's not necessary to cut two times because the equation of moments is similar. Okay, so I'm not going to explain in detail how to get the equation of moment based on the real diagram, because all the step and process is exactly similar in example 2. Okay, so if you look on the solution here, so actually the equation moment you have seen in the example 2, so it's exactly similar in example 2. Okay, so you may recall this based on example 2. Okay, how to get this equation. Okay, so I'm going to focus on this virtual diagram, okay, to get the equation of moment. Okay, so since we have two numbers of cut section, okay, so in actual they have three numbers of moment equation. Okay, we will just do one time here because the equation of moment is similar as I mentioned just now. Okay, so this is a solution. Okay, for the virtual load moment equation. Okay, so this is equation of moment equation for the first range 0 to 10, which is referred to member AB. Okay, so in this free body diagram you have a reaction, so meaning that you need to find out the value of reaction at A, okay, at the pin support here. So based on the three equilibrium equation, you can see that the vertical reactions of point A is equal to 0.5. So the horizontal reaction is 0. Okay, so based on this free body diagram, you can find out the equation of moment, which is equal to 0.25x. Okay, so for the second range is 0 to 5. So there's only a vertical reaction, okay, at point B, at support B, 0.5, and the internal moment. Okay, so and this gives me a moment equation of 0.5x. Okay, so and the next, you may to tabulate all the moment equation in the table. So as usual, you should have three numbers of a column here. First is the limit, second column for the real moment equation, the third column is for the virtual moment equation. And you can see here for the virtual diagram, the equation of moment is similar for range 0 to 3 and 3 to 5. Okay, but in a solution, it's just do one time. Okay. Okay, so this is a equation of virtual methods of displacement. Okay, and since we have three terms, you should to have three numbers of terms in the equation. Okay, which is for 0 to 10, 0 to 3 and 3 to 5. Okay, so by substituting all the equations of moment corresponding to the limit in the table and simplify this, so and you will see that this vertical displacement at joint C is equal to 0.22375 meter or 22.375 mm, and we got a positive value, so it just indicates that the direction of displacement is parallel to our assumption, which that we applied 1 unit load vertically downward in a visual diagram. Okay, so that's all for the example 5. So we will continue in example 6, okay, later on. So I hope that you still tune with me. Okay, see you.